All right, guys. So what we're doing today is we are going to continue talking about factoring. Okay. We have already learned how to factor with a lot of quadratics. So if I have something like x squared plus 2x plus 1, we have spent a ton of time learning how to factor that. But what we need to spend more time learning how to factor are problems that have exponents that are bigger than 2. So what we're going to do today is we are going to just kind of review factoring, and then we'll talk about some different methods and how to do different situations. Okay. So the key here, the very first thing you always want to remember is to factor out a greatest common factor first, because that will make your life so much easier if you are able to do that. Okay. So let's look at some situations if we have two terms. Okay. If we've got two terms, then that means that we have a couple of different rules that we could follow. Okay. The key here, though, is that they have to be in one of these three setups. If they're not in one of those three setups, then it's probably not factorable. So here's what I mean by that. If I have a difference of two perfect squares, okay, difference meaning subtract, squares meaning we multiplied the same thing times itself. So like 2 times 2, okay, then I can follow this rule. I have a squared, some term that's squared, minus b squared, another term that's squared. So for example, if I had 4x squared minus 9, okay, I can follow the rule a plus b times a minus b. So the square root of each of my terms. So for example, the square root of 4x squared is 2x, and the square root of negative 9 is 3. So my two factors would be 2x plus 3 times 2x minus 3. Okay. Well, if I have a sum of cubes, sum meaning add, cubes meaning to the third, like 2 times 2 times 2, or a difference of cubes, difference meaning subtract, cubes again meaning 2 times 2 times 2, then I'm going to follow a rule called SOAP. Okay. And SOAP, you're going to want to write this down somewhere. SOAP stands for same, opposite, always positive. Okay. And that rule applies to your signs. So if I have a sum of cubes, then I'm going to do my same sign in my first factor, opposite sign, and then positive sign, always positive. And my difference of cubes, I'm going to do same sign, opposite sign, and then always positive. So let's look at a couple of different examples together. Okay, if I have x to the third plus 8, okay, I want to see if I can take the cube root of both of my terms. And I can multiply x times x times x to get x to the third. So I'd say the cube root of x to the third is x. And then there is something I can multiply times itself 3 times to get 8. And that would actually be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. So then I just follow my SOAP rule. I have x and 2. Those are my two cube roots. I'm going to do the same sign. Oh gosh, the struggle with the stylus is real. Okay, so I've got plus in here, so I'm going to do plus in there. Then I have, let's go back to my rules. Okay, sum of cubes. I've got a squared. So my a squared, oh baby, okay, my a value is x, so I'm going to do x squared, opposite sign. Then I'm going to take a times b, so x times 2 would be 2x, and then my always positive sign, 2b squared is 4. So that's it. That's all I have to do to factor. Okay, let's look at the second one. X to the third, 8x to the third minus 1. Well, what's the cube root of 8x to the third? 2x. And obviously 1 times 1 times 1 is just going to be 1. So that's my A and that's my B. So I'll take 2x and minus 1. Take my same sign in the first one. Times a squared. A squared would be 4x squared. Opposite sign. A times b would be 2x. And then my same sign, or my always positive sign for the last one, with b squared. 1 times 1 is 1. Okay, last one. I've got 125 plus x to the third. So I need to find the cube root of each of these things. Well, x to the third's easy. We know that's going to be x. And then if I have 125, let's think. It ends in a 5, so maybe 5 can go into it. If I do 5 times 5 times 5, 5 times 5 is 25. 25 times 5, 25 times 4 is 100. So 25 times 5 could be 125. So 5 is my cube root there. Okay, so I'm going to follow my same rules. 5 is my A, x is my B. So I'm going to do 5, same sign, plus x times 5 squared. A squared is 25 minus opposite sign. A times b is 5x. And then b squared, x squared as my last term. Okay, so those are my factors for each one. Okay, I'm going to end this video. I want you to do the delta math. That is the sum and the difference of perfect squares.